Okay, so we're going to start into synthetic division. Synthetic is a shortcut to long division. So we're going to go through and show you how to use synthetic division to divide polynomials. So say you have a polynomial function f of x, and we're going to define f of x to be x cubed plus 2x squared minus 5x minus 6, and you are asked to factor. And we're going to say fully factor. Okay, so we went through yesterday and we learned how to use the factor theorem and the zero integral theorem. And how can we factor this polynomial? What are we going to have to do? So looking at this, we have to look at the constant term of our polynomial function, 6, and we list the possible factors of 6, which are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. We look at the leading coefficient here of our term. Our leading coefficient is 1. Factors of 1 are plus or minus 1. So it's not going to affect our factors at all. If there was a leading coefficient here, we would find the factors of our leading coefficient and then make a fraction where the factors of our constant are on the top and the factors of our leading coefficient are on the bottom, and those would be possible factors for our polynomial. Here, this is plus or minus 1, so our factors remain the same. So how do we figure out what our factors are, or what a factor is? What do we have to do? Sub in and guess and check. So which one do you want to sub in first? 2? Let's start with 2. So f of 2, 2 cubed plus 2 times 2 squared minus 5 times 2 minus 6. So 8 plus 8 minus 10 minus 6. F of 2 equals 0. So what does f of 2 equal 0? What does that tell us? Okay, so that tells us x minus 2 is a factor of f of x. And then we're going to set up our long division to factor our polynomial. So we can perform long division on the polynomial x cubed plus 2x squared minus 5x minus 6, and we divide that by x minus 2, and we get x squared plus 4x plus 3. What we'll do now is I'll show you a way to use synthetic division so you don't have to do this whole long division process. Okay, now we'll go through this exact same example using synthetic division. Now what we're going to do is we're going to set up our division statement. Once we get going on this, you don't have to write this above what we're going to be writing. This is just to kind of show you where everything goes. So what we do is we just take our leading coefficients. So we have the coefficient 1, 2, -5, and 6, and we make a table. Okay. We put a multiply symbol here. We put subtraction here. And we put the -2 here. Okay. So everything is just coming straight down. And that should be a -6 at the end here. Okay. So how to use synthetic division. First thing, this 1 drops straight down. So whatever's here, the first bit, first number, that drops straight down. Okay. From here, you take the 1 and multiply it by -2 to have -2. Then you're going to go to subtract -2 to give you 4. multiply by -2 again to get -8. Then we'll have -5 subtract -8 to give you 3. -3 times -2 to give you -6. And then -6 subtract -6 to give you 0. What's left here is your quotient. What's left would be your polynomial, your remainder here. So this is going to be 1 degree less. So here we started with an x cubed. So this will be your x squared. This will be your x. This will be your constant. So what's left here turns into the polynomial x squared plus 4x plus 3. This is your remainder of 0. Okay. So we can get the polynomial x cubed plus 2x squared minus 5x minus 6 equals x minus 2 times x squared plus 4x plus 3. So the second example we're going to do with synthetic division, a little bit harder. It deals with a polynomial 4x cubed minus 8x squared minus x plus 5, and we're going to divide that by 2x minus 1. The problem comes from this leading coefficient of the term that's in our denominator. Okay, if we just had, say, an x minus 1, we could go back to the example we did first, and we just bring down that x minus 1, and we'd go from there. Right now, this example we did has a leading coefficient of 1 on our divisor. So what we're going to have to do is kind of do a little work on our denominator. So we're going to take our 2x minus 1, set it equal to 0, bring the 1 over, so 2x equals 1, divide out by 2, so x equals 1/2, and then bring that back, so we get x minus 1/2 equals 0. So that's what we're going to take this and plug that back in for our denominator. And we can set it up looking the exact same. So we're going to have our leading coefficients of 4, -8, -1, and 5. And then we're going to have our -1/2, subtract, and our multiply. From there, it's done the exact same way. Our first term always drops straight down. So that's going to be 4. And then it'll be 4 times -1/2. Okay, so it's -2. -8 subtract -2, which is -6. -6 times -1/2 is +3. -1 subtract 3 is -4. -4 times -1/2 is 2. 5 subtract 2 is 3. This was an x cubed. So what's left here is going to start at a degree less. So we got an x squared and x. This is our constant. And this bit is our remainder. Okay, so we can say that 4x cubed minus 8x squared minus x plus 5 divided by 2x minus 1 equals 4x squared minus 6x minus 4 plus 3 over 2x minus 1. So we can write a division statement from the start of the unit. This one didn't factor perfectly, so we can't get our zeros for this one. But if you did work it out, it can work out that way.